Thanks so much. Thanks, everyone, and very much appreciated. Very tricky following Sean's exciting talk. So let me dive right in and just tell you a little bit about the research trajectory. I hope it stimulates a bit of discussion. It will look like I'm mostly going to highlight problems in AI, and that's actually not true. I note there at the bottom of this first slide that I'm actually an AI optimist. So I'm very keen and excited about the stuff that we're doing. The aim of this a very short intro is just to give you an idea of what I see as being the problems. I've put it all onto one slide here, but I'll just quickly mention them and then go into a bit of detail and see how we do time-wise. I think it's reasonable to say that algorithms are probably the single most important invention that humans have come up with. So I say this, of course, as an algorithm nerd, but algorithms drive the decisions that we take on a daily basis, whether we know it or not, but of course now facilitated by artificial intelligence. So it's very exciting in that sense. And the quality of outcomes, whether it's driving, cooking, business decision making, and so on, is all driven by the quality of the underlying algorithm, whether it's innate or more explicitly brought out. Quite a few of these algorithms are safety critical. So it's not acceptable to have these things have a failure mode, which is also very important. Coming up with new algorithms is remarkably difficult, but of course now we have algorithms that are creating algorithms. So this is the very exciting aspect of AI, and we knew that it was coming, but it also means that there's a tremendous body of knowledge already built up, but it's a fraction of what we actually need in the big picture. So that's the exciting angle to this, and I'll just mention a couple more of these as we go. So what have we gotten now with the arrival of generative AI? As it's already been pointed out this morning, it's not really the arrival. I mean, these things have been around even from before 2012, but nonetheless, it's really hit the news down. It's really big. So what have we gotten? Well, we've gotten a whole bunch of very cool stuff. It's worth noting that everyone's addicted to it in that sense. It's all about what can I now do with ChatGPT or a similar product as well. It has brought us much more natural interaction with apps. So instead of a lot of point and click, now we've got much more of a conversational aspect to this. So it's really lowered the human machine barrier a lot. So people involved in interface design are very excited. It's also got surprising functionality. So sometimes there's stuff hidden in there that we didn't even ask for. It's stuff that it just pops up with. It's changed our cognitive workload, so we're now explicitly offloading a lot more onto it. It's given us a lot of blue sky opportunities, so we can have domain-specific versions of these AIs. We can start dreaming about what we can do with these things. So that's all fine and good. And of course, it's a very much a dynamically expanding functionality. So what you thought you had today, tomorrow it'll be able to do even more. It typically is doing things that we want it to do. So it's growing in those specific directions and adapting to the interactions that we've had with it already. It feels, at least to us, that the construction of these systems has been painless. So they've just magically arrived there. Of course, that's not really true. So we know that under the hood, companies have done a tremendous amount of effort building them up, and we'll hear from Wolfram later on about that as well. And it's left us with a really interesting legal and ethical tangle in terms of plagiarism and of course copyright and creative outputs and so on. So what is it that we like about traditional classical software? So I just wanted to briefly mention this. Most of these things are actually lies that we know how to do this about software, or that we regularly do this. But in principle, we know how to get this done if we actually put in the effort. So classical or normal pre-AI software, we know how to specify systems. We even know how to give a formal specification of a system, writing it down and knowing what it should be able to do. We've got predictable construction of the system, so we can do this using correctness-oriented ways of doing that. We know how much time it's going to take to build a system, how many resources, how many programmers, and so on are going to be needed to build a system. It's inspectable, so we can actually go into it and we can look under the hood how it works. We can understand the system completely. We can build it in such a way that it's secure from privacy leakage, and therefore we're reasonably assured that we're not going to have legal problems with the POPI Act or GDPR or something in Europe. It's got predictable running behavior, so we can have it explain to us, or we can actually explain for ourselves why it came to a particular decision. We know something about the running time, the resources that it's going to use, how much memory, how many computers, how much cloud storage it's going to need. They're modifiable. So we can add new features, we can compose them with other systems, we can debug them and go in there and actually change something if we've discovered there's an error. And they tend to be behaviorally static. So a long time ago, it was already recognized that having systems that modify themselves, so-called self-modifying code, is actually a terrible idea. So they're behaviorally static, and that actually turns out to be a good thing. So those are all of the things that we claim that we love about classical software. And how does this hold up with artificial intelligence? And I just throw this up there because this highlights for us some of the things that we still need to tackle, if of course these are things that are desirable in the long run. So on the right panel there, you can see the things in particular that are yellow highlighted and struck out are the ones that we're not going to be able to do in the immediate future, and these are then some of the research foci. So one of them is, can we specify beforehand in a formal way what the AI system is going to do? And it turns out we don't have the mechanisms for that yet. So very exciting area for someone to do a PhD, and lots of people already working in that as well. Um, Predictable construction. We know how to build systems like ChatGPT in terms of the amount of time it will take to build them and the amount of computing power, but we don't know yet how to do a correctness by construction approach to that, where we build it up from the specification and we're assured that we've come up with something that we want. Building something that's inspectable. Can we actually look inside it, understand how it works? We don't know how to do that. It connects, of course, to the notion of explainable AI. So we don't yet know how to look inside a system that's run and then be able to understand really how it came to that particular output or how it came to that particular decision. So that actually is also remarkably difficult. Security from privacy leakage. We don't even know how to do that. The people interacting with ChatGPT or similar things are not really assured that the system's not absorbing all kinds of things from them. So this is a very important thing as well. Modifying the system after it's been built up. Do we know how to debug it? Go and fix a little bit inside the system. Also something we don't know how to do. And lastly, these systems are not behaviorally static, meaning that there's no way we can actually really stop it from growing and advancing. And that's actually, as we said, one of the real appeals of the system. So I'm at the time point, and I'm just going to show you what the rest of the slides look like, because I hope this stimulates in the discussion later in some of the questions. So there are known solutions in classical software. There are people that look old because they actually did a lot of this work in classical software more than 5 decades ago. So very important stuff. And I'll leave it at that. So thank you very much, Manoj.